Okay. Right, so I am going to be working on my 3D CAD, and I want to work on a new importer that lets me take SVG files, get all of the SVG elements, and then turn them into the 3D representation so that I can use it, for example, exporting to OpenSCAD or something like that. So let's think about how I actually want to go about that. That'll be the first thing. Let me actually swap around my workspaces here a little bit. Oops. Let's save that. By the way, I was working on seeing if I could get some sort of new approach to a file watcher sort of thing. And we're kind of there, but not quite. There's some work that needs to be done yet. Things are erroring out. There's obviously problems to sort out yet. But that's okay. It still is partially working. This is just a PNG file, so when I save the org file, it'll run a compile. It'll take this particular symbol, moth here, eval it through the SCAD exporter and everything like that, and then save a PNG. So if you have the PNG open, it'll automatically revert when it changes. So it'll look like it's live updating. It's not really, but it kind of looks like it. And it's not a good solution yet anyway. There are ways to improve it, but you see that it does change, which is pretty cool. You won't really see much of a change here when I change the radius of a sphere, but technically it does. It's supposed to change. There's also I'm ignoring a ton of errors that I really shouldn't ignore, but I digress. It also saves it into a state atom, so you can change it, or so you can look at it in the REPL by dereffing the state. All these errors are obviously needing to be fixed, but I'll work on that later because this is not actually the project I care about at the moment. So I'm actually going to do sysman quit. I'm just going to close this file out for now. Ugh. Okay. Sorry, no. I have to fix this. There we go. Okay, sound's working. We're good there. Oh, come on. Keep typoing this. There we go. No, let's save. There we go. Okay, so now we've got the Forge file here. Let me do good old-fashioned... Oh, actually, before I do that, let me just check. I can't remember if I spawned a REPL. No. Let's do this then. Let's focus first on thinking about how we can build a little pipeline for importing SVG files. That'll be the first thing to look at. Basically, we want an importer that takes an SVG file path and does a thing, and then will return the what would it be? The tree structure, the Forge model code directly. So to give a bit of context, or to give an example of what I actually mean by all that, I want to maybe I should load in pop into the Scratch namespace here. So, let's do a simple thing here. So I'll go ahead and do forge model, forge utils, compile scad. Let's get rid of compile SVG for now because it's not well implemented. I basically have to start that part over, but I'll get to that later. Compile scad is helpful because I have a tool that I can use to view scad stuff directly here. I can export to a SCAD file and open it in OpenSCAD directly. So I get a 3D representation like that is pretty close to one-to-one with the internal model I'm trying to build up with Forge. So it's a good testing tool. I quite like it. I am gonna clear out this plate stuff. I realize I don't, I'm gonna assume it's fine for now, but that's not at all what I wanted to do. Let's go ahead and shoop, there we go. Okay, so yeah, let's have a little load here, see if this works. We'll just establish a baseline. Let's do cider REPL toggle content types. Oops, I should be enabled, not disabled. With that enabled, I can view PNGs right in the browser in the REPL with relative ease. So let's build this, this, and this. I say build, I mean eval. And if I show C, it's clearly working there, which is fantastic. Let's change this up a bit, by the way, just so it looks a little cooler, I think. There's a nice donut there. Let's do this 30, and this is going to be 8. Point is here, I can quickly change and see things. Hey, Thrashton, how's it going? Still closuring? Yeah, of course. Wouldn't be giving it up anytime soon. Working on 2D, 3D modeling tools with Clojure. That's where I'm at. I'm assuming you're still doing good old Common Lisp and having a good time with that. Still lisping, yeah. Perfect. Naturally. Love it. Love to hear it. Hope things are going well with you these days. Let's see. I am working on, you're doing a huge project right now. Is it for work, or is it a personal project, or maybe both? Who knows? I hope it's going well. That sounds exciting. Personal, kinda. Sounds like, if I had to guess, and maybe I'm totally off base here, it sounds a little bit like you have a friend with a cool idea, and you're the one implementing some of those details, and they're a little more business side. That's a total guess. You have a team now. You are a friend with a cool idea. I gotcha. I'm not mocking it. That's amazing. That's the best way to come up with teams, right? People with ideas and initiative, finding other people with initiative and skills. Boom, you can make nice stuff that way. So sounds cool. I wish you the best, of course. You want to add parametric type polymorphism to Common Lisp. So yeah. Well, that's no small thing, I'm sure. Well, so I would imagine you might be able to make a proof of concept thing, like a really small scoped thing, fairly effectively, and then extending that scope to be more and more practically useful is what starts to take a lot of time. You already did a lot of it. Nice work. Oh, so do you enjoy doing that project? I kind of hope so, for your sake. Done in small parts, yeah. All right, let's see. Where am I at here? You like how dispatch mostly happens at compile time, which was the goal. Nice. Yeah, that makes sense. It's really nice to have a lot of stuff happen at compile time, right, when you can. Just keep things really quick, straightforward to execute. That's the word. Can you tell it's a Monday? Oh my goodness. All right, so I'm in the middle of trying to go for performance. Yeah. I have so this is I want to show you something that's super not performant, but is like a helpful little tool at the start of just messing around with stuff. Performance is like a struggle with me sometimes, but sorry for distractions. Oh, no worries. If I really need to focus, it's my choice to look at or ignore chat. You know, it's up to me, right? So you can feel free to chat. I mean, if anything, you could have slightly longer message. Like you could put more in a single chat message, and that would be slightly less distracting. But don't worry about it. I can control where I put my attention and where I focus my eyes, so should be okay. But talking about performance, it is an important thing. I want to see if I can give you a really bad example. I've got this here. I'm working on what's a good here? Well, let's load up the file and make sure things are working anyway. Source forge frep.cljc. That should load. Clojure isn't the fastest language as far as I can tell. As far as I forget what, as far as I see. Whatever. Yeah, you're right. I mean, I don't need it to be the most blazing fast thing anyway. And in many cases, you can actually get good performance out of it with all kinds of stuff, but I'm concerned. Oh, as far as I'm concerned. Oh, I see. Parsing. Natural language parsing. That's the thing I was struggling with there. No, so for ultra fast, you know, I don't need it to be the fastest thing on the planet. That's not what I'm getting at here. But I threw this together really quick because I'm working on these things called functional representation of 2D and 3D stuff. So for example, if I use the function circle, I want to give it a radius of 20. This circle function returns a function itself, and that function then returns a distance to the edge of the circle. So if I def a as a circle of radius 20, now I run a, it's a function that's expecting a 2D point. So let's do 0, 0. It gives me the distance to the edge of that circle, which when you're right in the middle of it, it's going to be equal to the radius of the circle. In this case, it reports a minus, but I think that's related to how I implemented it. Oops, that's my bad. This should be, yeah, see that? It changes it a little bit there. So if I do, for example, 20, 0, the distance should be 0 anywhere on that circle. This will be greater because it's outside of the circle. So using those distance values, you can actually map on a grid, a 2D pixel grid, if your pixel is inside or outside of the circle. And then using that, you can render it, right? So really quickly, I threw this together. It puts an SVG circle at a pixel and then sets its opacity based on the distance. So right away, I should just be using a PNG thing directly, not my SVG library, but I was lazy. I made it work quickly, right? So obviously there's improvement to be had using the correct tool, but I wanted to see how fast or slow it was anyway. So let's use this cider show function here to show A and see what's up. I'm pretty sure this should work. Yeah, so there you go. It didn't take all that long, but you can imagine if I'm just testing... Oh, sorry for outside noise. There's, I can't control the outside world, but I want my window open, so hopefully it's not too bad. Anyway, the point is, for graphic stuff like this, especially something as simple as a circle, you would want the utilities for viewing that thing to be as quick as possible, right? So this example is not at all meant to be performant. I didn't want to, that wasn't the intent. But you can see very quickly where this is a spot where you do ultimately, on a final solution, you really do want good performance so that you can get, you could eventually do animations, you could make a WebGL thing, you know, use actual 3D, all that kind of stuff. Yeah, but so it's cool that it's in the REPL, by the way. Yeah, exactly. So it's still like there's still good utility for building it up kind of purposes, and obviously I like the REPL workflow like this enough that I do want this part to be optimized at some point in the near-ish future. Gonna get something similar in Common Lisp soon. That's cool. Drawing in the REPL. So the thing is too, there's probably better ways to do this in the REPL. This was just something I figured out quickly. So what it's actually doing, it's saving a PNG file to, like it's saving it to disk, right? Then it's creating a Java IO file, and then the REPL tool I have here, Cider, can detect the header of that it's an image and then display it on my behalf. So I'm just using built-in tools here, and probably there are more appropriate ways to kind of better integrate the tooling. But as a starting point, it's not too bad. I'm pretty pleased with it, to be honest. The other thing too is you can do, I also have this function here, show render, which will open it in a web browser. So you could use that if you're not in a Clojure REPL, for example. And here you can see in the browser here that it's an SVG of it's an SVG full of rectangles. So I'm literally making SVG rectangles for each pixel, right? So you can see how that is not going to scale up particularly well. But it's pretty neat, right? I think I'm pretty pleased with that so far. Now, the obvious problem here is I needed to be way, way faster because I do care about 2D functional representation, but what I actually want to be using this for is 3D stuff. So you can imagine that if I'm doing loops over X and Y values, right? If you add another dimension to it, you need to loop over X and Y and Z. So you multiply, you know, if you want a volume of 200 by 200 by 200, you have to do 200 cubed, which is a big number of calculations, right? So there's, you know, you want to kind of optimize that. You want to be smart if you're checking in Z, that if you already have a value that the camera can see, you don't want to check any more Z values behind that because it'll be occluded anyway. So you don't have to calculate anymore for that pixel value, and all that kind of stuff I have to start building in, but I haven't yet. So that's a visual example of how it's nice to get a proof of concept without worrying about optimizing. But then it's very obvious sometimes where it would pay to actually spend the time and optimize it. But that's not what I'm doing today. Today I'm working on, well, actually, I want to swap these windows around here so I have this in the middle. It's a little nicer. Right. What I want to do today is work on another importer here. So I have this image importing tool, which, I should Let me contextualize that a little bit here. Let's make sure that it's still working just fine. Cool stuff, man. Thanks, I appreciate that. Yeah, I'm pretty happy with this. As things go, things are coming along nicer and nicer. I'm getting closer and closer to like since I started this, so there's kind of two main libraries I work on: SVG, CLJ, so using SVG stuff with Clojure and Clojure script. So that's all two-dimensional graphics stuff. I mean, you can use it to, if you do the right transforms, you could do an isometric projection and all that stuff. And then the other thing I have a lot of interest in is 3D, so CAD development. That's CAD software tools, what I really love to work on. And as I've been going, I've had that idea, loosely speaking, in my head from the start. And as I go, I realize more and more that, oh, okay, this is how it would actually make sense, and doing that. And the actual structure of the libraries I'm building is becoming clearer and clearer, which is very exciting. There's still a lot of room to work on things, but we're getting closer to something that's more and more useful, which I'm super happy about. All right, so this image importer, what's a good way to show this off? Let's see if I can get it going. Well, let's first of all, let's load the file up. SourceForge import image.clj. Currently, this will only work in a Clojure context. It won't work on Clojure script. Not at the moment anyway. I have to figure out how to make it work. But that's, again, a problem for another day. This here, if I define using this drawing function, I can pass it a PNG file name and get a useful set of points from it. So what's a good well, I'll use this. I know that I have a PNG that's kind of useful already here. If I do design moth sketch, I think that's, yeah, okay, so what I just did there, right? I loaded a PNG and I got out of it a data structure of points, polygon points. So what happened is this PNG I ran through a tracing program that saves it to an SVG. I load the SVG and I pull the data from the SVG itself into this structure that I can then use in 3D contexts. So what does all that mean? Let's do well, let's define B to be model extrude A by a height of 100. Let's give it a weird thing. Okay, so that's some 3D structure. This should work. forge.compile.scad slash show. No, cider show. Yeah. B. There we go. So what just happened here, this is part of a little art project I did. It's a here, maybe it makes sense to show the PNG here. Let's do design moth sketch eyes.png. That's all it is. It's a white background and black pixels. Then it gets traced, converted to polygon points. Then it gets used in a 3D model context, which I think is amazing. I think that's so cool. So you can use this, right? You could draw out on an iPad or even on a piece of paper and take a picture of it. You could draw shapes out and use them as a sketch basis for some 3D models. Now, would it be dimensionally accurate? there's some tools I want to build to kind of smooth and optimize different geometry, but those are algorithmic considerations. I already have the ability to trace a thing and put it into point data, which is super useful already. Now the reason that only works on Clojure at the moment is because I haven't implemented the, oops, I closed the wrong window. Oh well. I have not done the tracing algorithm myself. I use an external program at the moment. But that will come with time as well, because it actually doesn't look too complicated. Famous last words, of course. But I guess it seems just complicated enough that I could figure out how to do it with, you know, reference to code and papers and stuff. But anyway, point is, I can use some of that. There we go. Don't need that. Excuse me. There's a few. There's a few assumptions built into the pipeline here for importing PNG images. I want to be able to import SVG files as well. And in order to do that properly, I have to actually add some more detail into this approach. So, what I think what I think would be smart is something like this. If I do something like this. Call it import PNG, something like that. Then I need to make a new function, import SVG. Okay, that'll take file name, and it'll do similar things, not the same things, but similar. It'll take file name, and it'll be an SVG string after I do. So in this case, I'm assuming this function will be designed to take in an SVG file name. So it has to be that coming in. Here, this has to be a PNG file name. And then I'll make an interface function that will just, whatever file you pass in, it'll check the extension, I guess, and then dispatch to the right importer. That seems fine for now anyway. Might not be the final design, but to get it working, that seems okay. Right, so here, the next thing I want to do is slurp that file name. Now it'll be, at this point, it'll already be an SVG string. So in fact, what I need to just do here is take string to elements. Then, for the time being, just for now, I'm going to call that good. So let's build a little test SVG file to work with here. Simplest thing I can think of let's do... Okay, so we've got an SVG circle of 50. So let's now I just want to think of the fastest way to do this. SVG clj dot tools slash show. Okay, I forget. Okay, so that file does still exist. Okay, so let's move temp.html to test.svg. We'll call it sketch.svg. How about that? So now if I slurp sketch.svg, incorrect. Oh, I'm in the wrong. Well, that's silly. Let me do this. Remove out.html, remove sketch.svg, remove image temp, remove. That's good. Now we gotta get into the Forge directory. Easy enough. So here, move temp HTML to sketch.svg. There we go. Now if I slurp that, it should work. Okay, so we can see in here, it's a small SVG file, super simple, but there's the circle with the radius of 50 built in, exactly like we saw, or exactly like we would expect, I mean, right here. Let's also close that. Don't need it. This is another project I had going on. It's related to a few other things, including this tattoo here, but that's a digression. Right. Sorry, I have to handle this message for a second. Okay, onward. So what I want to check is if this import SVG function works already, at least in some capacity. Okay, so that's promising so far, right? It's not bad. Basically what it'll do is that it'll just spit out a list of elements that exist in there, and all I really need to do at this point is convert the SVG representation into the internal representation of the Forge library, which honestly should not be too bad. Let's pull up a reference. Let's get SVG CLJ in there. Let's open up the file, and what I need to check is that basically I just need all the shapes represented, and that's not actually that many, which is really good. I have to check something here. Let's go to the model. Basically, everything's going to exist in the 2D thing here. So circle, boom, got it. Ellipse, need to make an ellipse function. Our X, our Y. Ellipse. Yeah, perfect. Okay. Okay, circle, got one. Ellipse, got one. Line, got one. Polygon, got one. Polyline, got one. Rectangle, got one. I also have text and group and image, which I think I won't. That's gonna be a whole other ball game. Image and text I'm not gonna worry about for the time being, because those are gonna be tricky no matter what. G is nice and easy. I'm happy with that. So really, a lot of this shouldn't actually be too difficult. Basically, what I just need to do is, anytime I encounter those particulars, I just have to, I just have to make sure I convert them into the appropriate structure with the appropriate translations and stuff like that, that'll be where the slight challenge comes from. So I think what I need to do in order to make this work, oops, that's not at all what I meant to do. Utilities, no? Oh. Okay. Okay, oh, that's draw wing. That's not what I wanted. Yeah, so here, let's split this off. No, sorry, I need to. Wait a second. This is an incorrect place to store this, actually. This should be in oh, come on, that's not at all what I meant to do. Yeah, so that should be in the SCAD compiler tools folder, as it were. because that's not an importer, it's an exporter. It'll take the model data and it'll use OpenSCAD to make a 2D sliced SVG file. Yeah, so it's making a file, it's not importing a file. Anyway, blah blah blah. Not important right now. It's beyond. Oh, one little problem. Oh no, it's not a problem. I should do this though. Just for consistency here. Kinda ugly, but better than nothing, I suppose, for the time being. Okay. Back to it, please. Back to it. Ba ba ba. Okay, so this one is going to be SVG to model. Right, so methods for converting all SVG elements into equivalent model. Oops. Forge model elements / transforms. Right, so elements being converted. Right, circle, ellipse, line, polygon, polyline, path. Yeah. Rectangle. G. Right. Some of these are super easy, but let's begin at the beginning. Def multi function. I suppose we'll use a similar thing here where I do this. Right, we're gonna call it SVG to model. Is the thing there. And it's gonna work on a single SVG element. It's gonna get the keyword. If the element doesn't have a keyword, it's gonna assume it's a list, and then it's gonna work per list. So SVG to model, it'll have elements passed in because it's a list at that point. Then it's just a matter of doing something to each of those things, which will be, in this case, SVG to MDL model over the elements, right? Basically, that should be it, right? Let me think about it just for 1 second here. Map, blah, blah. Yeah, that makes sense. Let me fix this up. Map, SVG, oops, model. Oh, I don't need to wrap it in that because it SVG to model over the elements like that. Boom, now we're cooking. So that means the next thing to do is def method SVG to model of a circle, And so when we're given a circle, right, it's going to look like this. It's going to take an element in. It's going to have the tag is going to be circle, so we can just leave it as is. We know we don't need it. Circle is going to have props. So if I do SVG CLJ dot elements slash circle 20, right? It's got key and then the properties here. And the properties themselves, all we're gonna need for it, let me think about, if I have to remember something here because it's been just a tick. Let's map SVG CLJ dot elements slash circle 20 over SVG CLJ dot transform slash style, and we'll style it with fill blue. Yeah, okay. See that? Maybe a bit of an issue. The reason I'm thinking about this is it might be useful to recover or maintain style data, because I eventually want to flow styling through my whole process anyway, in a way that is intuitively similar to common styling standards, web styling, that sort of thing. 1 second. Ba 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 ba. Right. Let's we'll take keys. I know for sure there's CX, there's CY, and then there's radius, and then everything else as props makes sense. So what I actually can do here now actually, some of this is not too hard. Let me just check that. Am I importing this Forge model? Yes, I am, right here. Is this actually necessary here? I wonder if I should get rid of the compiler stuff, because that might lead to circular dependencies. I think I only had that in there for testing purposes. Yes, that is the case. Pretty sure that's correct. We'll explore that later, but let's actually delete this now so that I force myself to pay attention to it. Right. Oh, sorry, I'm just looking at the decibel readout of the outdoor noise. It's not perfect, but it will be okay for now. Anyway. Where was I? Right here. So let's just do let there's a function, Clojure con thread, I think. Let's try it. Con thread. Model / circle taking R. Then right. Then and CX is 0 and CY is also 0. Wait a second. It's the complement of these things, so it's not. I mean, is this smart or stupid? Is not equal even a thing? I don't remember. We will find out soon. Okay, it is. Good. Right, so when CX is not 0 and this is not 0, then you pass the condition and you do model translate the circle by sorry, not what I meant to do. CX, CY, 0. I kind of think that actually should work, right? Let's see here. So let's go ahead and do this circle. Let's def that. Okay, so now A is that circle, and we can see if it'll convert nicely. Let's do SVG to model of, am I in the right? Yes, I am. Of A. It does do that. And then I should actually be able to, from here, do this is why that works. Okay. And let's do one more quick check here. Let's do Trying to think what I need to do. forge.compile.scad/cider show, sorry, SVG2 model of A should, yes, okay, that's really good. So that proves to me, I could even do, let's do this here, model/extrude that thing, which is a 2D shape, by 10. Yes, it's working. That is fantastic. Now, actually, I should check. Let's go to def A here, and we'll pop another transform on there, because now I need to translate it. I need to check that that works. Translate. Uh, 120. Looks no different, except, well, maybe it is no different, and I have to fix that. Oop. Okay, perfect. The translate is right there. Yes, okay, that is fantastic. This is now pretty straightforward, honestly. It shouldn't be that hard to do the rest of these. So, well, let's just go ahead and do it. Ellipse, I won't test, but I'll build it. The reason I won't test it is because I haven't implemented it across everything. Although, I probably could implement it pretty easily, but that's a problem for another time. Let's do this. $20.50. Okay, so the ellipse has CX, CY, RX, RY. Otherwise, it's the same. Sweet. And I just realized actually that there is one other thing I can do here. So if I let XF props, so transformed props, be dissociate map key and keys. Yes, so I can do, let's dissociate A1, B2. Let's dissociate A. Oh, no, I don't think I need it to be a list. Yeah, if I dissociate A and B, it's nothing. If I dissociate A and B and C, it's nothing. Okay, so I can use that. So let's dissociate from props. Oops, props. The keys, CX, CY, because those are the ones that are they're not strictly speaking needed strictly speaking, they're not needed at all in the context of the internal representation, so I should dissociate them. Although arguably I could actually just leave them in there because it's not a big deal, but I should keep the structure a little bit clean. I think that's a better idea. Right, so using that new props, all I need to do here is const thread, and then here true, so this guarantees that it will work. This is a little unwieldy. I don't necessarily love this approach, to be totally honest. Only for readability issues, so it's not a big deal. Right, what I should then do model/style No, let's actually no, we should do that. Model style xf props. Okay, so that's good, except that in the model I don't have a style function, so we'll make one in the transforms quickly. Translate, rotate, group. Group is not really a transform, but alas, it's gonna stay for now. Let's also put it here. Yeah, that's fine, right? Let's take this and do style. Oops. I want to use the SVG style as a reference here. It's super simple. It's not even a method, it's one single function. And in this case, I do wonder if I should no, you know what, I'm not gonna overcomplicate it. I'll literally make it the same as this, so we'll do that. Yeah, style takes the element and then the style map. Load file, source, forge, model. Let's try it. Model slash circle 20. Model slash style. Color blue. We'll make up, it's a fake, it's not a real property yet, but you can just use that. And it bakes it in, which is perfect. In this case, I think that's a good idea. We'll see if it ends up being, if it ends up continuing to be a good idea or not, but we'll figure that one out. Let me check here actually if oh, this is not going to work very well. So now that leave it in there for the time being and figure it out as I go. That's what I'll do. Okay. It at least doesn't, it does capture all the stuff. It's just maybe not putting everything in the sensible spot is all. Yeah, so to fix that, I actually could make it a multi-method, and for the, I could just have default be this style, and then on specific transforms I could change its behavior so that it bakes it into the children, not into the transform itself. But I'm not going to worry about that right now. I want to think about one little thing at a time, and that's going to be back at the import of SVGs. Oop. Here we are. Let's give this another go. Ooh. No, symbol R in this context? Well, of course, this is going to be wrong. This is honestly hard to read. I don't like it, but it does make sense. So we'll go with it for now. Yeah. So this circle should work now. If I have a look at this here, let's change this to fill, a real style. Oh, but that's also not what I wanted to do. A is an ellipse now, fill blue. Let's find a new A, or let's redef A as the circle for a second. Circle 50. B is the ellipse. A is a circle. B is an ellipse. Perfect. Now let's run SVG to model on A. Translate. Has the fill blue in it already. Okay, so yeah, it ends up being a problem right out of the gate. Well, actually not quite. Let's swap this around. There. That should fix that for this case. Puts the fill there as opposed to there. I'll have to think of a right way to handle that, but for the time being, I'm going to just roll with it. Now here, we paste the same approach. Model, ellipse, Rx, Ry. Otherwise, it's the same. Okay, so now we run it on B. Translate ellipse, fill is there. Ooh, yeah, I don't need that. That'll be confusing. Yeah, so we dissoc. Yeah. I wonder if I should just have a like some kind of dissoc list. Removable. It shouldn't be a function either. It just needs to be list or a vector of these. Cx, cy, transform, and then we can add to that as we go. So if I define this, oop, I'm a little surprised at that. Okay, well, what's the syntax for I think it's like, where's the hat? That's not what I meant to do. I think it's like this. I don't know what I'm doing. It doesn't matter. I'll just def. Let's see. Clojure make def private. I was close. No, no, not at all what I wanted. Ugh. There we go. Okay. Def private, removable props. CXCY transform. Yeah, so we can do removable props. That should work. Seems to. Okay, let's see. No more transform. Good. Likewise with the circle. Promising. Very promising. Okay, so let's keep going. Circle, ellipse, line. Okay, so let's now def C is just going to be SVG CLJ.elements / line. Perfect. X1, Y1, X2, Y2. Oh, wait, what? Now I gotta be paying attention here. There we go. Make it a little function actually. Apply dissociate to all this. Oh. Yeah, this will be a little bit easier to read. So clean props, I can make it private because it is only really useful in this context. CX, CY, transform, might be others. Probably a bunch of CSS properties, although I want to be careful not have like a massive list here. I just want to the things that I know are commonly in there. And anyway, the nice thing is it's not actually a problem if there are unneeded keys in these maps. The only time it becomes a problem is if I'm saving it to a, like if it's a massive data structure and I want to write it out or something like that. It seems unnecessary to store excess keys that you won't need. Blah blah blah. It doesn't matter. Yeah, that should just work, right? So if I do xf props as just clean props, clean props, that should fix these right up. Perfect. The line should even be easier than this. I shouldn't need a cons. I don't need cons at all. Model. Line. It's going to be x1, y1, 0, z. And this one's going to be x2, y2, 0, z. And do the transform. I don't need to translate it at all. There's no translate. It's gonna just be what it is. Ooh, pros, props. All right. C is this line, so if I do SVG to model of C, it turns it into a normal line, which I should be able to compile scad cider show SVG to model of C, should make a black line. Looks strange, but it does work. It's very good. Very happy with that. Awesome. That's great. Line. I'm gonna do the polygon in a minute. I'm gonna go to the washroom though first. There it is. Okay. All right. Let's get going. Polygon. I realized something. Something that's probably gonna be an issue. So I might need to rethink eliminating the transform thing, just because there might be an SVG built by some other program that actually does use the transform property to let's see, I have to think about that. Probably want to bake that into the SVG library directly. And I'll a little tired today. Okay. Let's make a polyline. Polyline. There's only one key, points, clean props. I don't know why I spelt that, was weird to do polyline that way, but that's okay. Points. Oops. Keys, points. Oops. There we go. Oh, did I overwrite? I overwrote my old. Ooh. I did something wrong. Oh, yeah, right. This list of points isn't a list of points that I need. It's not in the format that I need. It's in a string format. That's not good enough. So I need to do svg clj dot utils slash string. I think it's S to V like this. I hope that's correct. Yeah, okay, so let props be clean props. Let's let points be the result of doing a few quick things to this. So we need to take points, run it through utils is SVG utils here, so we've got to run it through utils slash string to v to vector. Then we run that through partition 2 partition 2, right? That'll turn this list into a list of points, right? Should be. Let's do that. Partition 2. Now I need them to be, do I need them to be anything more than that? Maybe not. Let's see if it works. Okay, let's give it a try. Seems to work. Okay, that's promising. Next, polyline. Oh, I should have done this as polygon, but it'll actually end up being basically exactly the same. Polygon. Right, so let's check. Let's def C. We'll just switch this word polyline for polygon, and then we'll incorrect. This has to be polygon. Now this should be different. Yes, perfect. I'm loving that. Okay. Polyline, polygon, let's do rectangle. Elements, rectangle, 20 by 40. Width, height, X, Y. And model slash rectangle has uh 20, 40. I should change these to W and H, actually. I'm going to do that now before I completely forget about it. Model, 2D, rectangle, rectangle, width, height. Width, width, height, height. Excuse me. I know I need to change that in the SCAD compiler, so I'm going to do that before I forget here as well. Rectangle, keys, width, height. Easy. Okay, so load file, source forge model, COJC, and source forge compile SCAD. That's confusing to me. Why is that like that? Where did that come from? Yes, that would be here. If I do yeah. So this has to be, this does, that's gonna be a bit of a bummer, don't you think? Yes, I do. Well, I should do it this way. Yeah, this is gonna change later, but I'm doing the lazy thing. It's just gonna be forge dot import. That should fix this. Okay. Right, so model slash rectangle width height, good. And now forge.compile SCAD slash cider show model slash rectangle 2030 should, yeah, it works. So that's helpful. That's a good thing. Right, close the tools here. Compilers, back to this. Okay, so right, C, this is an SVG rectangle. SVG to model of rectangle keys. The keys I need for sure, width, oh, I just get a width, height. I do also need X and Y, and then I need to do a check, basically. Let's see, let's think about that. Transform props is that. Position is going to be a calculation where since the rectangle is assumed to be centered in the 3D context, I need to be able to calculate the center position using the X and Y and the width and height of these. So in order to do that, let me think about this for just a second. I actually just need, so I know that the position for C is 0, 0. So how would I get 0, 0 calculating these things out? So it's actually just going to be x and y plus half of the width and height. So all I have to do is util slash v plus yeah. Yeah. That's true. That should be true. Width divided by 2. And, oops, wrong. Height divided by 2. So that's the position. And I'll do this. And I could just do something like this. So model rectangle taking width and height. Then model translate conj onto position 0, and that's your translate. Okay, let's see if that works. So let's do we've got to do SVG to model C has a translate of 0, 0, which is exactly what I would expect. Looking good. Okay, so then the rectangle, right, has a width and height of blah, blah, blah. Oh, here, let me add to this. Ooh, wait a second. Could be risky to remove things called X and Y. Yeah, because I have X and Y here. A and B is important. Points is important with height. Radius, RX, RY. Points and paths, I need that. Slice Z, I need that. Yeah, so I can't. I mean, I could. Maybe it's not a problem. I could just add it back in or do additional dissociations for more specific cases, but should be relatively okay. So let's try it again. Actually, let's just do this. Let's just double check that. Oh. There we go. Looking good. So now, quick test. Looking good. Looking very good. Now, basically, it looks like the last thing I need to do is the group element. I think that's right. SVG to model of G. Model group. It just tags group and then does that. So if the input to this is props and content, and please, why am I always forgetting? There we go. And content. Let's go with this as a basis. So if the count of elements is 1 and the first part of the first element is not a keyword, that means content is a list of elements. So you just do first LMs. Otherwise, you filter complement nil of LMs and put it into the G tag. Ooh, why is that wrong? Right, and the only difference here is I call it group instead of that, and I do props in case it has props associated already. Oh, one other thing. This has to be XF props because I need to still follow the let XF props be clean props of props, and take this, wrap that. Where'd I go? Okay. Ooh. Def method. There we go. Okay, so let's group those things, right? Let's def D as SVG CLJ dot elements / G AC. So now if we have D, we've got a group. Oh.
I don't understand. Hey Siri, so now we have Debbie got a group.
Ugh. Okay, good. Accidentally activated Siri, which is not what I want. Oh my goodness. Okay, I gotta keep working. That's what I gotta do. Okay, so this G is defined. Now we've got D is an SVG group. Now let's do ooh, interesting. There are errors. Okay, well, let's do SVG to model of D. So it's a group, and the group contains the circle, and the rectangle, and they're unchanged. They do not have SVG to model on them, which makes sense actually. I do need to yeah, I should do this, right? Map SVG to model over the rest. Oops. And likewise here. That should hopefully fix it. Group, translate, circle, translate, rectangle. All right, that looks pretty good. Let's see if it'll show. Don't know how to make blah 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 from let's see what this looks like. Okay, so it looks the same, and it won't work, I think. Yeah. Okay, that makes sense, of course. Let's go have a look at the logic of this here. Actually, let's see. Wait, where is it reporting the error from? Forge compile SCAD. Yeah, that makes sense. So go into the SCAD compiler, why don't we? And have a look at the implementation for transforms. I think I put it in here. Translate, rotate, scale, mirror, whole, offset. Oh, I probably put it in other here. Okay. Right expression of a group. So if we look at D, I just didn't change this at all. So it is the wrong signature. It has to be like a Boolean one, right? It's gotta be, oh, sorry, actually now just need to be model union SVG to model of A with SVG to model of B or C. Union, yeah, so union does what it kind of what I want it to. And that more or less works. Group elements. Okay, so this, I don't need this map cat business anymore. I can actually just make it write expression LMs like that. Right, and if I model group, it's that, but if I model union, it's a list of those things. Yeah, so I actually want it to have this structure. So I have to go, so the compiler is fixed there. Let's fix the model now. We've got to do group and elements, whereas something like where am I at here? Boolean, it does take and elements and just returns elements directly, but here let's do and elements. Right, so I'm actually just going to get rid of a bunch of this stuff, so I should just do and elements group. Yeah, that'll work just fine. Group empty props elements, and that should fix it. So let's load those files. Load file, forge, model, and compile SCAD. Looking good. All right, now let's go. Group AB looks good. Okay. Let's find our. Okay, that's promising. Now, that's working. No. Okay, so I did the same problem now here. So we've got the model fixed. Now we got to go back to our importer, image, SVG. Let's head over here. Okay, if, let's blow all of this out of here, we don't need it. We need to let. Yeah, so here now, we're in the let. We need to do group xf props map SVG to MDL model over elements. Okay, let's try that. Group with that. Okay, very good. Now, hopefully this renders when I run the cider view. Yes, okay, that's fantastic. So we've got a group working. Excuse me, sorry about that. Apparently I didn't sleep perfectly last night and now I'm a little bit tired, but hey, we're making good progress, so it's all fine. It's all good. Okay, that's a group tag. Right, so is that enough? Well, let's take this to its logical next step, right? So we've got import PNG and import SVG. So I've just built out something that should, in theory, map over all of the elements and convert them properly into model components. Then all I should need to do is either group them or structure them in some other way. Though I think grouping them makes the most sense. Oh, also I am not quite done. There is really important path elements that I'm not covering yet. That'll be the most important thing, probably. Okay, so path elements take the shape. This is going to be a bit harder because a path element can contain more than just straight line data. It can contain arcs, Bezier curves, and stuff like that. So we could unfortunately end up with a bunch of weird stuff happening. How do I want to handle this? See, the thing is, I have some of the basics here for different path stuff, but let's just go with the straight polygon approach for now and extend that when we need to. And that actually is not so bad because there's already this here. SVG path element to polygon. So using that, where is that? Wait a second. Where's this come? What did I just miss here? Oh, it's right here. Okay. SVG path element to polygon. So, given a path element, run all of these different things. I'm just thinking about this here, flip Y. I'm pretty sure if I just use this to convert my SVG path elements, that they'll all be flipped and nothing else in an SVG will be flipped. So that's not necessarily a good thing. For the sake of getting somewhere, I'm gonna just let it be okay for now and fix up the logic as I go. This, by the way, can actually go up here. No, this actually, it really should go here. And B. That should just, it should just work. I think that makes sense. And we'll do it this way. Props. Right, so path, key props, that's fine. Actually, we'll do even easier. It's going to be an element. We don't even need to destructure it. We're just going to run SVG path element to polygon, and then model style. Oh, we do need. Is this gonna work if I do props as LM? I don't know if this works in that method of destructuring, but that's fine. I can, if it doesn't work, I'll just use a let. Right, model style. Oh, I need a let here anyway. So let's boosh that in. Okay, so let xf props be clean props of props. Then model style xf props. Oop. Seems to have worked. Right, so let's def. That's not what I meant to do. D circle rectangle A circle B ellipse. See that D is a group. E doesn't exist. Okay. Right. Def. Let's start over at A. It doesn't matter. A is going to be SVG CLJ dot path slash path poly polygon path, and it has a list of points. 0, 0, 100, 100, 50, negative 50, path, fill rule, even, odd. Yeah, that's fine. Right, so to make that work, didn't work. I didn't actually run it through anything, of course. Try again. Hey, that looks promising. So we've got a difference containing, oh, we need to fix this up here. We need to make D and fill rule disappear and run this again. Right, so when, we should for sure make the difference disappear when there's no, right, when split path, where's the right spot to put that? Well, let's fix this up like this a little bit. Let's do a let polygons So polygons equals this whole thing. You do all of that, but here, this one, we gotta get rid of this. So polygons is a list of polygons. It could be one or many lists. So if the count is 1, you don't do a difference, but if it is, yeah, so let's just do if the count of PGS polygons is greater than 1, then you've got to map it through oops, come on. Right, so if polygons is blah 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 blah, right? You just do we don't need to do this weirdness. Apply difference to the polygons. Yeah. Otherwise, you just return first of polygons. And that should be okay. I think that'll work. So let's try that. Right, so we've just got a single polygon. Now, if I were to do, let's def A and B as two different things. So if we def B, I want to modify it. 10, 10, 90. Merge A and B. Yeah, there you go. You do get a difference of polygons now. Perfect. That's exactly what I wanted to see. Let's def C as SVG CLJ.path/merge paths A, B. All right, perfect. So now, using all of that, we should be able to do forge, compile, SCAD, CIDR, of, not of A, but of SVG to model of A. Huh. It didn't work. I'll have to figure out why. I mean, it rendered, but it's not right. Okay, gotta work on that then. Points and paths. Oh, well, so there's this weird thing going on. Why is that happening? I don't know. But well, let's do model/polygon. Of these points. Copied too much there. Okay, so there is one thing going wrong, I guess. This polygon, will that show? Gotta copy that. Ah, okay, so there's something going wrong with something in here. It's just this adding this extra thing here. Yeah. If I do that for C, it does the same thing. So there's something with this. This is wrong. Somehow this is incorrect. Is it in the flip Y? Let's check that. Why don't we? It is kind of there. Sorry, I have confused myself somewhat. This here polygons. There's a nil. Okay, so map path to points. Is it map path to points that introduces a nil here? Let's check that out. Right. That, I bet the Z, is that it? Okay, let's have a look at map path to points for a second. Here it is. So when the last yeah, it's got to be if I do this, right, if I do into vector filter sum, that should fix this problem, I think. Let's go back up here. Wait a second, where did I? Oh no, I changed the right thing. We're good. Okay. Oop. Okay, there we go. There's no more nil there. That's related to paths with a Z ending. It means it's a closed path. Versus, it basically makes it a polygon, but I'm kind of, for now, assuming already that it is a polygon, not a polyline, and excuse me, and all that other stuff I'll have to work out in a more detailed fashion, probably in the SVG library directly, because path manipulation is going to be an important aspect of that library anyway. But using that, I think we're basically done with this. Let's just sensibly check that this is going to make sense. That's all still correct. This flip Y is probably, I'm not sure that's a smart thing to do, you know? Might be a bit of a mistake. But let's go with it for now. Okay, so import SVG string to elements now should have, it should work now if I do map SVG to model. So let's give it a try. Import SVG, file name is sketch.svg. Looks like it worked. Right, if I do forge.compile, cider show, import SVG, sketch.svg. Yes. Okay, that is fantastic. I realized I didn't check yet. Cider show SVG to model of C. Yes, it works. That looks weird because it's well, because I made weird paths, but it does work. So, oh, that's really good. Okay, I'm very happy with that. And that's gonna be all for me for the day. Yeah, don't have much to say. I'll be back streaming tomorrow. Hopefully I have a YouTube video out soon. Gonna be working on that tonight yet. That's all I got. Have a good one. I'll be back tomorrow.